here's the final problem for our practice problems video. We have find the exact solution and interval of existence for y prime is equal to e to the x plus y. And then our initial condition is y of 0 is equal to 0. So here I'll label this the initial condition, and this of course is our ODE, right? So ODE here. Alrighty, so let's go about finding our general solution first. So dy over dx is equal to e to the x plus y. And we can rewrite the right side by writing as a product of two quantities, right? So e to the x times e to the y. So here we can divide by e to the y on both sides, divide by e to the y, and multiply by dx on both sides, multiply by dx. Okay, kind of just ignore this guy right now. So these cancel out as well as do the dx's. So we get 1 over e to the y dy is equal to e to the x dx, okay? And here the left side, I'm just going to rewrite that as e to the negative y dy, okay? And then this is equal to e to the x dx. And what we're going to do now is just integrate both sides. So we get negative e to the negative y is equal to e to the x and then plus our c. Okay, so at this point, what I want to do is just use our initial condition to figure out our constant c, okay? So I'll just rewrite it here. So negative e to the negative y is equal to e to the x plus c. And we're just going to plug in when, so our initial condition tells us when x equals 0, our y is equal to 0. So let's plug those in. So we get negative e to the 0 power is equal to e to the 0 plus c. And both of these quantities are 1, okay? So we have negative 1 is equal to 1 plus c. So c is therefore equal to a negative 2, okay? So here we're going to have negative e to the negative y is equal to e to the x, and then we have a minus 2 there now. Alright, so now we're going to try to solve for y. So what we can do first is multiply by a negative 1 everywhere. So that would change the signs on everything. And we get e to the negative y is equal to negative. Well, we could just write 2. The signs just flip, right? So 2 minus an e to the x. Alright? And we'll continue this on the next slide and we'll solve for y. So we have e to the negative y is equal to 2 minus e to the x now. And what we're going to do is ln both sides. Alrighty? And we can put absolute value signs there if we want. Alright. So now we have something that looks like negative y. This negative y just comes down, okay? And we're left with ln absolute value of 2 minus e to the x power. Alright, and then all we have to do is just multiply by negative on both sides. So we get y of x by itself now is equal to negative ln times of the absolute value of 2 minus e to the x. Okay? Or we could also write this as I did have a professor once who used log instead. I don't know if it depends on your professor's notation and what they prefer. Or they used this to refer to ln. So you could write it like this. I'm more familiar with this form here. Okay, so this is it. This is our particular solution here. And now what we need to do is explore or examine the interval of existence for this. All right. So while our ln, first of all, it's undefined whenever we have something that is either equal to 0 or is less than 0 in here. Okay, well, it can't be less than 0 because we don't have to worry about that because we have these absolute value signs. So in our case, whatever's inside can just not be equal to 0. Okay, and like I said, we're allowing it to be less than 0, and of course it can be greater than 0, but we are allowing it to be less than 0, whatever's on the inside, because we have the absolute value sign to correct it. Okay, so here we can just not be equal to 0. So that means 2 cannot be equal to e to the x, which means when we ln both sides, that means that x cannot equal this ln 2. Alright, so whatever x can be anything except for this ln 2, so that kind of forms our possible intervals of existence into being negative infinity up to ln 2, and we have our rounded bracket because we don't want to include it, but in union with ln 2, again a rounded bracket, up to positive infinity. So see how here these intervals are kind of shaped around ln 2 and we're not including that value there. Alright, so now our final job is to determine, okay, so which one of these is our interval of existence, and we're going to look back at our our initial value given, our initial condition, and it was y of 0 is equal to 0. So that means that our x is equal to 0, and in which interval is that? That would be the negative one here, or the left one, okay? So this is our interval of existence there. Alrighty, so we could just rewrite it as negative infinity up to ln 2, okay? That's our interval of existence, and again, this is our particular solution right there. Okay, so that concludes our practice problems video for section 2.2 on separable equations. I hope that helped, and good luck on your homework.